use Green's theorem to evaluate the integral around the closed curve x squared y dx plus xy squared dy, where the region, the enclosed region, is a function xy such that x is between 0 and 1 and y is between 0 and x. Now, just a reminder of what the formula is for Green's theorem. It says the integral around a closed curve of a function p dx plus another function q dy is equal to the double integral around the region of partial q by partial x minus partial p by partial y dy dx. Now, you will need to see what the graph looks like, do a sketch of it, do the double integral, identify the correct boundaries, alright, and do your identify p and q, differentiate them, and do your double integration. Now, I have worked this out before and I got -1/6. So if I didn't make any mistake, that would be correct. So I'm going to ask you to pause the video, work it out, and see if you get the same thing. Okay, good. So you have finished. Did you get -1/6? Let's see what's going on here. It says p dx. P dx. So you can see what p is, right? Q dy. You can see what q is. So in this case, p is x squared y. Alright? And q is xy squared. So what's the partial of q with respect to x? Partial q by partial x would be, in this case, it's y squared, right? And then partial p by partial y equals x squared. So you can see that, alright? Now, that means you're going to do a double integration around a region of partial q by partial x, which is y squared minus partial p by partial y, which is x squared, dy dx. It could be dx first and then dy, but I usually prefer doing dy first and then dx, since doing dx first would require transposing an equation. Alright, anyway, here, what are the boundaries? Let's get an x and y axis. It says x is between 0 and 1. So along the x axis, you go from 0 to, say this is 1. Y is between 0 and x. So what that means is that this line is really y equals x. Alright? If this is above 1 and y equals x, then this would be beside 1, beside y equal 1. Right? Okay. Now, what are the boundaries of the double integration? If you consider these elements, where for each element the width is delta x, changing x and the height is delta y, and you stack them up from floor to ceiling, you would be going from 0 So let's look at the y first. How does y change? As we go up, you're changing y. So it's dy first. It's from 0 to, where will it stop? It always stops on the line. If you come here, right, it will be higher. So it stops on this line. So it goes from y equals 0 to y equals x. Okay? And then along x now, when you stack them up from floor to ceiling, upwards, then you have to go sideways in order to fill out the entire space. So you have to be stacking them up sideways now to fill out the entire shape, right? So you're going from left to right, from x equals 0 to x equal 1. Okay, good. Now, here, we have the first integration that we'll do. It's the inside one, the inner integration. So we wait on the x part, the integral from x equals 0 to x equals 1 of something dx. Let's do the inside integration first. When you integrate y with respect to y, no, I mean when you integrate y squared with respect to y, you get y cubed over 3 minus, when you integrate x squared with respect to y, you get x squared y, because remember you're treating x as a constant for now. Are you going from y equals 0 to y equals x? So let's rewrite this integration dx. Okay, I wrote this dx kind of far away. Let me put it nearer. I won't write the dx until I fill out this space, because I might write it too near or too far. This one here, y, you're differentiating with respect to y. So you're going to substitute the upper boundary x and the lower boundary 0. So when you substitute x, y becomes x. So this is x cubed over 3 minus x squared times y, which is x. Okay? That's the upper boundary minus. The lower boundary is 0. So this is 0 cubed over 3 minus x squared times 0. Okay, so you integrate all of this dx. Alright. So later we're going to do an integral from x equals 0 to x equal 1. When we simplify all of this, well, this part will be 0. 0 cubed is 0, 0 over 3 is 0, minus x squared by 0 is 0. So you don't have to worry about this part out here anymore. It says x cubed over 3 minus x cubed dx. We could simplify this, you know, because when you look at it, if you integrate from x equals 0 to x equals 1, this, you know, is 1/3 x cubed minus 1x cubed, you know. So you have 1/3 minus 1. What is 1/3 minus 1? 1/3 minus 1 is same as 1 over 3 minus 3 over 3, using common denominator. So 1 minus 3 is negative 2. So it's negative 2/3 then. Alright? So it's negative 2/3. So this is the integral from x equals 0 to x equal 1 of negative 2/3 x cubed dx. Okay, good. Now, let's integrate this. When you differentiate x cubed with respect to x, you have x to the 4th over 4. And you have negative 2/3 of that. And you're going from 0 to 1. So now, well, 2 to 1, 2 to 4, 2. This is going to be negative 1 over 3, 2, 6. Negative 1/6. X to the 4th from 0 to 1. So when you substitute, you have negative 1/6 times 1 to the 4th minus negative 1/6 times 0 to the 4th. Alright? So you have, well, 0 to the 4th is 0. 0 by negative 1/6 is 0. So this minus 0. So you don't have to worry about that. 1 to the 4th is 1. So all you're left with then is this negative 1/6. Write it on that. Equal to negative 1/6. Okay, good. So that is that. The answer is negative 1/6.